to chapter 11.1.1 worksheet. What we're going to be doing is figuring out the surface area and the volume of some pretty basic shapes, rectangular prisms, triangular prisms, and then I'll do a cylinder as well. So we're going to start with surface area. You can see I already got a head start on problem number one. Surface area essentially is if you were to paint it, right? We're just talking about the surface area. So how much area is on the outside of the surface of this thing. So what I've done is I've broken it into the front and the back. You can see the front would be 4 by 3, and so would the back. The top would be a 4 by 4, and so would the bottom. And the left and right side would be 4 by 3. So what I want to do is just sort of break this into the faces of it, or the surfaces of it, so that I could figure out what the surface area is. And again, like if I wanted to paint it, here it would be 4 times 3. I would need 12 square meters of paint. Here I would also need 12. Here I would need 16, here I would need 16, here I would need 12, and here I would need 12. So I think it's a lot easier to calculate the surface area by actually going through and figuring out how much surface area is on each particular face and then adding them together. So 12 plus 12 plus 16 plus 16 plus 12 plus 12. Well, it's going to be easier if I go 12 plus 12 is 24 plus 16 is 40 and double it, so 80 meters squared, and that doesn't look great. So let me see if I can get slightly better handwriting. 80 meters squared is going to be my surface area of this shape right here. Now, if I want to calculate the volume is going to be, this isn't erasing as well as I had intended for it to erase. There we go. I still can't delete that stuff, huh? I have to click on them individually. Ugh. This is taking longer than it should. I apologize. Okay, so if I want the volume of it, I thought I was getting ahead by doing this. I really should have paused the video. I apologize for not pausing the video. It would have made a lot more sense to have done that. Well, that's 20, 30 seconds of your life you're never going to get back. So when we go ahead, man, I really should have paused the video there. I apologize. Okay, so what about the volume? The volume is, if we looked at this like a fish tank, essentially how much water would it hold? So volume is going to be meters cubed because it's in 3 dimensions. And essentially what I'm going to do is I'm going to figure out what's the base, and it's 4 times 4 is 16. So there's 16 meters squared here, but then it goes up in this direction for that 3rd dimension. So it's going to be 48 meters cubed is what I'm looking at on this particular shape. And again, it's just multiplying in 3 directions, 4 times 4 times 3. And you can see as I multiply by 3, that begins to fill that volume up. So what do I do when I have a triangular prism? Well, again, if I do the surface area, which I'm going to, I know it's going to be centimeters squared, and I know the volume will be centimeters cubed. So I'm going to break this into I have the top and the bottom, and you can see it's 15 by 12. And here's 15 by 12, and again, that's 15 and that's 12. So I need to figure out what this is. Okay, I have the sides. So this will be, the right side is going to look like a rectangle, and it's going to be 10 by, I don't quite know what this is yet. I'm going to have to figure this out, but this one I know. The left side I know is 12 by 10. And then the back face of it, I know, is going to be 15 by 10, right? If you just can visualize that is 15 by 10. So I have most of this figured out, but I really need to know what this distance is right here. So what I'm going to do is I'm going to use the Pythagorean theorem. Again, if this is 12, well, this is 12 as well. So I know that 12 squared plus something squared equals 15 squared. So what I'm looking for is this distance, and again, I'm going to make that a triangle. So I'm going to say, all right, 12 squared plus x squared equals 15 squared. 144 plus x squared equals 225. X squared is going to equal, let's see here, I think it's going to equal 81, but let's verify that. So I'm going to say 225 minus 144 is going to equal 81. And I need the square root of that. So I know that x is going to equal 9. So you can see there's a lot of visualization that goes on with this. So again, this one right here was 9 by 10. And now that I have each face, I will go ahead and determine, I know this is 90, I know this is 120, I know this is 150, I have the three sides. Well, what I need is, I need the area here. And what I essentially have is a triangle, and I need the base and I need the height. So if we call this the base and that's the height, I can just say half of the base is 12, right? By the way, just so we're all clear, the area of a triangle is half of base times height. So I'm going to call this my base and this my height. So half of my base is 6 times 9 is 54. Half of my base is 6 times 9 is 54. So I'm just going to add all these up. 54 plus 54 is 108. 108 plus 90 is 198. Plus 120. Plus 150. It looks like I get 468 centimeters squared. But if you'll recall, what we said was the volume, I want to get the area of a base and then just multiply it by the height. We already have the area of a base is 554. And now I can just multiply the height of 10 to get 540. Again, I hope that makes sense, right? I already have the area of this base, and it's 54, I've determined. Now I just need to multiply it by this height. 54 times 10 is going to be 540, and that's going to be the volume of that one. And finally, what I'll do is I will go ahead and solve one of the cylinders, just to give you an example of each of the three types of shapes that we're going to look at. And I guess what I'll do is I'll do problem number 6, since I get a pretty good look at it and the other ones are kind of covered. So let's go here. And let's look at the surface area and the volume of number 6. So again, when I do the surface area, I know that it's in 2 dimensions, and I know that the volume's in 3. So to get the surface area, I have a top, which is a circle. I have the bottom, which is a circle. And then if you imagine a can of soup with the label, the side of this is actually a rectangle. And like I said, if you can just imagine a soup can, if you split that label and unfold it, it turns into a rectangle. So the side of a cylinder is indeed a rectangle. So now what I need to do is I need to figure out the area of each of these. So my area of a circle is going to be pi r squared. So I need to know what that radius in it is, and apparently it's 5. So I'm just going to plug in 5 here. It's going to be 25 pi. And I'll grab my calculator, and I will see what 25 pi equals. So 25 pi is equal to 78.5. I'll just call it 78.5. So I know that this has an area of 78.5, and I know that this is the same. The top and the bottom are the same. And now what I need to do is get the area here. Well, I need the circumference, right? Because that's this label. If I split it down the middle, the circumference is going to be this part right here. So what's the circumference of a circle? Well, the circumference of a circle is going to be 2 pi r, right? So the circumference is 2 pi r, which means it's 10 pi, right? 2 times 5 is 10 pi. 3.14, so it's just 31.4. I'm sorry, 31.4 is going to be my top. Now I need my height is 2, right? So again, if I'm looking at this as a rectangle, this becomes my top, which is 31.4. This becomes my side, which is 2. I multiply the two together, I get 62.8. So if I want my surface area, I need to add 78.5 plus 78.5 plus 62.8. I'll add those up. Carry the 1, 9, 17, 19, 8, 15, 21. I get 219.8 meters squared. So if I was going to paint this cylinder, I would need 219.8 meters squared of paint. Now the question is, what about the volume? And again, the volume is going to be the area of a base times the height. Well, I already have the area of a base. The area of a base is 78.5. So I'll just multiply 78.5 by 2. I'll double that because the meter is 2. And if I multiply that out, let's see, 1, 16, 17, so 15. I get 157 meters cubed. So again, it's all about visualizing it, being able to break these pieces into their smaller parts, and then from there, the volume, once you have that surface, and once you have the area of the base, you can just multiply it by the height. I hope this makes sense. If there's questions, feel free to ask them. We're going to move into some more complicated shapes as the chapter goes on, but these are 3 basic shapes.